For the increasing power of my thermoacoustic engine, I need an efficient way to convert mechanical to electrical energy. I tried a turbine, oscillating stepper motors, a common slider crank drive, and a simple linear generator. So far, nothing has really been satisfactory. For this reason, I would like to design and build a powerful linear generator using the finite element method and the FEMM program. For this, I need strong magnets, powerful coils, a reinforcing iron core, and a stable but smooth running linear bearing. With this design, I hope to efficiently convert the energy and support our solar plant with inexpensive, self-generated power during periods of low sunshine. For years, I have been producing my own energy using self-generated biogas and my self-built Stirling engines. Converting the mechanical energy produced by my engines with kinematic gears using a conventional generator is no problem. My mechanical Stirlings are also very powerful and a lot of fun, but unfortunately they are too expensive and maintenance intensive to be used to produce our own energy economically in the long term. For this reason, I consistently try to avoid all meshing elements that cause friction, wear and high costs. My current approach with a very elegant thermoacoustic engine theoretically does not require any moving parts. Unfortunately, it is impossible to extract electrical energy from the motor without moving parts. That is why this conversion is so important for the engine. My first radial linear generator was very simple in design and low in power, but it worked in principle and was quite elegant in concept. To increase the engine's frequency and avoid balancing for the moment, I have made various lightweight plastic pistons, and I'm also conducting tests again with piston rings that still come from the kinematic Stirling engines. I studied the arrangement of energy converting components in various electric motors, linear motors and large commercial linear generators, and learned the basics of induction and the path of the magnetic field lines. The concept is very similar for all these machines, and I've used it to define an initial basic structure for myself. FEMM is a free program for solving electromagnetic problems using the finite element method. I simulated the various magnet, iron core and coil arrangements and discussed them with you on YouTube and Discord. Once again, a big thank to you everyone who helped me so much with their contributions and discussions. The contact and exchange with you is the true reason why I make these videos. The many fresh ideas, helpful suggestions and proposed solutions are very motivating and incredibly valuable for my work. Without your help, I would not be able to make all of this happen. So, if you are not already doing so, please be active by writing on YouTube and Discord. I read and respond to every meaningful comment and give a lot of thought to your suggestions, criticism, requests and ideas. Oh yes, a membership on Patreon or YouTube would also help me a lot, of course. I'm currently thinking about spending less time on my main job and more time working on these projects and making videos about them. I would have much more time for it if I earned some money with this work. So please subscribe, turn off your ad blocker and support me on Patreon or YouTube, if you can. After finding the optimum design using FEMM simulation, I moved on to the design stage using FreeCAD, where I had to take into account the available materials and inexpensive components. For the iron core, I have 5mm thick pure iron sheet metal in my scrap box that can just about withstand the required magnetic field strength without reaching saturation. The coils are wound from 0.5mm copper wire. I will experiment extensively with the number of turns and adapt them to the constantly changing engine power. MGN07 linear guides ensure stable, lightweight and low friction mounting. The 10x10x30mm N45 neodymium magnets are much stronger than I thought, and I will have great problems attaching them properly to the iron sheets. I will now continue with the manufacture and assembly of the linear generator and hope to be able to report on the first performance tests soon. I will gradually upload the CAD files, 3D models for 3D printing and drawings to Patreon and the members area so that you can take a close look at the linear generator and build your own. As always, I'm very grateful if you send me plenty of criticism, suggestions for improvement, ideas and requests here on YouTube or Discord. This is very important to me. Special thanks to my supporters on Patreon and all YouTube channel members. Without you, none of this would be possible. Thank you very much for your interest.